Hello dear students, welcome to XII International School online classes. This is your second video of class 12. In the previous video, we had studied about the charges, that is what is electric charge. We had studied about the properties of charges, the SI unit and many more things. You can go through that video. Now in this video, we'll cover the remaining two properties of electric charge, because in the previous video I had explained the two properties. Okay, first was the fundamental law also, if you remember, that like charges repel each other and unlike charges attract each other. So this was the first property. Second property, that charges are conserved in nature, that is neither created nor destroyed. We know that it can be transferred from one body to another body. Okay. Now the third property, that the charges are additive in nature. Okay. Now what is the meaning of additive in nature? That means we can add the charges, or we can calculate the total number of charges by simple integer. Okay. That means just simple algebra, we can find out the total number of charges on a body. Fine. That is the third property, that is charges are additive in nature. The fourth one, which is very important property, or we can say that is the first formula we used to see in class 12, that is quantization of charge. Now what is quantization of charge? It means, so in very simple words, first I say that we can calculate the total charge on body. See, there is difference between the number of charges and the charge on body. Okay, number of charges, that means we are talking about number of electrons or protons, and charge on the body, that means we are talking about its effect, that property. Fine. So we can calculate the total charge on the body by just multiplying the number of electrons or protons by the charge on electron or proton. That is, if we have n number of electrons or protons on a body, then the total charge will be, that is Q is equals to n times the charge on electron or proton. That you can see that Q is equals to plus minus n into E. Now what is E here? E is the charge on single electron or proton. The value we had already studied, that is the value of E mathematically, E equal to 1.67 into 10 to the power minus 19 Coulomb, if you remember. Okay, so we can calculate the total charge on a body, that is Q equal to Ne, where N is the number of electrons or the protons and E is the charge on electron or proton. Fine. So now on the macroscopic level, we can use this property, say quantization, but microscopic level it is very difficult to calculate the total charge, because we don't know actually the number of charges. That doesn't mean we cannot calculate the charge on a body. Yes, there are different methods qualitatively, in fact quantitatively we can calculate the charge on a body, that body contains how much charge, that we can calculate. But with the quantization, it is difficult to calculate the charge on a bigger bodies, where the number of charges are almost infinite, that infinite in number we can say. Okay, so macroscopic level, yes, quantization is valid, but microscopic level, quantization is not valid. Fine. So these are the properties of the electric charges, or characteristics of the electric charges that we had studied. Fine. Now let's move on. The next topic is charging of a body. How we can charge a body. Fine. Now how we can charge a body, there are three different methods given in NCERT. Okay, like as I said in my previous video, the body, usually the objects are neutral, that means the number of electrons and protons are equal. Like I said, we can charge a body, that means a body can lose electrons or gains the electrons. Fine. Now by three different methods we can do that. This is called the charging of a body, the next topic which I am discussing right now. The first method is charging by friction. Okay, now in this what happens, the two bodies comes in the physical contact with one another. Like suppose if I have a glass rod and a silk cloth, then if I rub the glass rod with the silk cloth, then the glass rod acquires the positive charge. Now what does it mean? It means the glass rod has loose electrons. That is why it acquires positive charge. And then what about the silk cloth? 100% it will get a negative charge. Why? Because the charges will be transferred from glass rod to silk cloth. That means by friction, that is by rubbing two things, that is if the two bodies are in physical contact with one another, and in physical contact if one body is rubbed over the other body, then we can say that two bodies will be charged. Okay, now basically charging means losing of electrons. Okay, if a body loses or if a body gains the electron, we can say it will be positively or negatively charged. As I said earlier, if a body loses electrons, then it will positively charge, and if a body gains the electrons, it will be negatively charged. Fine, so that is charging by friction. The second method is charging by conduction. Okay, in this method also the two bodies are in physical contact with one another, but there is no rubbing in this one. Okay, means the rubbing of the two bodies. We can have a charged body, and with that charged body we can charge the another one by taking it in the physical contact. Like as in my previous video I had taken example of balloon, if you remember. Okay, that if we take the balloon and if we rub it, then and if we stick on the wall, then what will happen? It will stick there. So what happens? The charged balloon, okay, maybe positively or negatively, whatever. So if that balloon is charged, then the uncharged wall, it stick on that one. Okay, how it sticks? That when the charges on the surface of the balloon, they repel the same charges and the opposite charges get attracted. So in this also we can see that one charged body charged the another neutral body and it gets stuck over there. That is charging by conduction. And the third method is charging by induction. The another method in which, but this method is little bit different, in which the two bodies are not in physical contact with one another. That is another very important topic of NCERT. It is given there that how we can charge the body by induction. Okay, in this one what happens? Suppose if I have an uncharged sphere and if I have a charged glass rod. Now we know that glass rod acquires the positive charge. Now if I have that positively charged glass rod, and if I take that glass rod in front of the uncharged sphere, as you can see in the diagram, then what happens? The like charges repels and it get over the other surface of the sphere. And if we connect the sphere with the earth, then the charge will flow to the earth. Then the body will be negatively charged because the electrons will be attracted with that positively charged glass rod. In this way, we can charge the uncharged sphere. Similarly, if I have another rod which is say negatively charged, say ebonite rod, that is negatively charged. Now if I keep that negative charge rod with that neutral in front of that neutral glass rod, then what will happen? Neutral sphere, then what will happen? That neutral sphere will be positively charged. Why it will be positively charged? Because the negative charge flow through the conducting wire to the earth, as you can see in the diagram. So these are the different methods of charging the body. Let me revise one more time. Charging by friction, charging by conduction, and charging by induction. So these are the three different methods to charge a body. Okay, now we'll see the electrostatic force, the next important topic, that is electrostatic force exerted by the electric charges. It is very important, as from the name itself, we can see electrostatic. That means it is a kind of force, repulsive and attractive. It's a kind of force exerted by the charges when they are at rest. Electrostatic force of attraction or repulsion. This we have to see. Fine. One of the scientists, Charles Augustin Coulomb, he had calculated the magnitude of this force. Okay, this force, we can say this is one of the natural forces in which we had studied in class 11th also. There are 4 natural forces that we had studied there. So this is one of the very important force, electrostatic force of attraction or repulsion. Okay, now, like electrostatic force, you had studied another force in class 11, that is gravitational force. If I'll explain you here, you will see that it is more like gravitational force. Okay, but we know that gravitational force is only the force of attraction, not repulsion. But electrostatic force is force of attraction as well as repulsion. That means, like the first law, fundamental property we had studied, that like charges repel each other, unlike charges attract. That means if we have 2 different charges of different nature, that is an electron and a proton, say negative and a positive charge, then they will attract each other. And if we have 2 similar charges, similar nature charges, like if we have 2 protons, 2 positively charged or 2 negatively charged particles, then they will repel each other. Okay, so quantitatively, Charles Augustin Coulomb had calculated the magnitude of the force. Okay, that is called the Coulomb's law for electrostatic force, which is the very important topic of class 12. Fine. Now the law is very simple. We can easily understand the law. It basically gives the magnitude of the force, as I said earlier. Okay. Now if we have 2 charges, Q1 and Q2, of say same or different magnitude, same or different charge, nature that is. If we have 2 charges separated by a distance r, then the force of attraction or repulsion between these 2 charges is directly proportional to the product of the magnitude of the 2 charges. That is, F is proportional to Q1, Q2. Here Q1 and Q2 are the magnitudes of the 2 charges, and inversely this force of attraction or repulsion is inversely proportional to the square of the distance between the 2 charges. That means if the charges are separated by a distance r, then the force of attraction or repulsion is inversely proportional to the square of the distance. Fine. Now if we combine both, that is F is proportional, directly proportional to the product of the charges, that is Q1, Q2, and force is inversely proportional to the square, then we will get F is proportional to Q1, Q2 by r square. Now we know that we have to remove this proportionality sign, and after removing we have to write the constant, and here the constant is K, called the proportionality constant here. Now the very important part, now you can see the formula that F equal to K Q1 Q2 upon R square. Here K again is the proportionality constant, but it is a very important constant, and it also gives the difference between the first between gravitational force and electrostatic force. The first difference I had discussed earlier, that electrostatic force is force of attraction and repulsion also, but gravitational force is always force of attraction. Now the second difference, that the gravitational force does not depend on any of the medium. It is independent of the medium. But the electrostatic force depends on the medium in which the 2 charges are kept. The value of K, as you can see, is 1 by 4 pi epsilon naught. Now this epsilon naught can be written as epsilon also, epsilon or R also. That we'll see. Here the epsilon is the permittivity of the free space, epsilon naught is the permittivity of the free space. The value of 1 upon 4 pi epsilon naught is 9 into 10 to the power 9 units. But here students get confused that what is actually this epsilon naught here. That is, what is this permittivity of free space. Now dear students, as I said, that this force of attraction or repulsion the force between charges, depends on the medium. So this permittivity constant or this permittivity, that means basically that how much that particular medium is giving permission to exert the force on each other, whether the force is force of attraction or force of repulsion. That medium provides, or that medium you had seen permittivity. Now you can just break it. Permittivity, permit, permission. That means how much permission that particular medium gives to those charges to apply force on each other. Okay, so once again, according to Coulomb's law, the force of attraction or repulsion between the two charges is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square of the distance between them. If we combine it, we'll get F equal to K Q1 Q2 by R square. Here K is the constant, proportionality constant. Its value is 1 upon 4 pi epsilon naught for free space. The mathematical value, as I said, 9 into 10 to the power 9 unit. That is the mathematical value. Now for different mediums, the value of epsilon changes. Okay, in the next video, we will see the vector form of Coulomb's law, which is another very important. Fine. So that's all for this video. Thank you.